Hello students, this is K. Sarkar. Here I am covering the topic motion. I have earlier posted a video on motion, but some students said that they have not understood. Okay, so I am again explaining this topic. So first you have to know what is rest and what is motion. You know that an object is said to be in a state of rest if it does not change its position with respect to its surrounding with time. Okay, if any object does not change its position with respect to its surrounding with time, then you can say that object in rest position, that object is in rest position. Like chair, table, tree, they do not change their position with respect to their surrounding and time, so they are in rest position. On the other hand, if an object changes its position with respect to time, with respect to its surrounding and time, then you can say that object is in motion. Okay, like car, motorbike, flying birds, they changes their position with respect to their surrounding and time, so they are in motion. Okay, then motion can be divided into 5 categories. Okay, basically motion can be divided into 5 categories. What are they? Rectilinear motion, curvilinear motion, circulatory motion, rotatory motion, and oscillatory motion. Okay, so motion can be divided. Motion is basically divided into 5 categories: rectilinear motion, curvilinear motion, circulatory motion, rotatory motion, and oscillatory motion. Okay, now rectilinear motion and curvilinear motion together called translatory motion. Okay, so what is rectilinear motion? If an object follows a straight line or goes in a straight line, then you can say the motion of that object is rectilinear. Okay, like cycle goes in straight line, apples falls from trees. Okay, these are rectilinear motion because this motion they moves in straight line. Okay, on the other hand, if an object follows a curved line, or if an object changes its position in a curved line with respect to time, then you can say that object is in curvilinear motion. Like train follows a curved track. Okay, so you are you can understand what is the difference between rectilinear motion and curvilinear motion. In case of rectilinear motion, the object follows straight line, and in case of curvilinear motion, the object follows curved line. Okay, and rectilinear motion and curvilinear motion together called translatory motion. Okay, now comes circulatory motion. Circulatory motion is easy. If an object follows a circular path, or then you can say it is in a circulatory motion. Okay, if the object follows a circular track or it follows a circular path, then you can say the object is in circulatory motion. Okay, like if someone cycling along a circular track, then you can say that person is in circulatory motion. Okay, now comes the rotatory motion. Here some confusion may occur. Okay, so you must understand, you have to understand what is difference between circulatory motion and rotatory motion. So first I am giving example of rotatory motion. The example of rotatory motion is the movement of fan. I have drawn a picture here so that you can understand. Okay, see the topmost part of the blade, the black part of the blade, they are covering a bigger circle. On the other hand, the middle part of the blade, they are covering a smaller circle. Okay, So same object but different part of that object covering different path with respect to time. When a fan move, or when a switch on a fan, the fan follows a circular path, but different part of the fan follows different type of circle. Okay, so each part of the fan follows circulatory motion, but different part of the fan follows different circulatory motion. That is, the circumference of the circle are different. Okay, so this is called rotatory motion. So what is the difference between circulatory motion and rotatory motion? In circulatory motion, every part of the object follows same circle, but in case of rotatory motion, different part of the object follows different circular path. This is the difference between circulatory motion and rotatory motion. Okay, and then comes the oscillatory motion. Okay, example of oscillatory motion is movement of pendulum. Here I have drawn the pendulum. Okay, this portion, this round portion, or it is like a sphere portion known as bob. Okay, and the bob is hang from a support, rigid support, and it is hang by a string. Okay, so this total object is known as pendulum, and the sphere part is bob of the pendulum, and then from where it is hanging, it is the support, and it is hanging by the string. Okay, so when pendulum moves, pendulum goes from here to here, and then again here to here. Okay, so this is its starting position, then it comes here, it is its mean position, and then it comes here, it is its ultimate position. Then again it's come in this position, this mean position, and again it's goes to its ultimate position. Okay, and then again it's come its mean position, and then it goes to its ultimate position. Okay, so the pendulum goes from point A to B, and then again from B to A, and in the middle it has mean position. Okay, so this type of motion is known as oscillatory motion. So what is the difference between circulatory and rotatory motion and oscillatory motion? In case of oscillatory motion, in case of circulatory motion and rotatory motion, the object covers a full circle. Okay, the object covers a circular path. In case of circulatory motion, every part of the object covers a same circle, but in case of rotatory motion, the object moves along a axis, and different part of the object follows different circle. Okay, but in case of oscillatory motion, the object do not follow that object does not follow, okay, the whole circle. It is a fixed path. Okay, it is a fixed path. It has a initial position, then it goes in mean position, then it goes its final position, again it return to its mean position, and again it goes to its initial position. Okay, so it does not follow the circular path. Okay, but it follows a part of a circle and return. So it has initial position and final position, then it returns to its mean position and goes to its initial position, then it's again start, and it start from its initial position and come to its mean position, and then goes again to its final position. Okay, so now this type of this total thing is called oscillation. Okay, when it start from its initial position, then it comes to its mean position and goes to its final position, and again return to its mean position, and again goes to its final position. This total is known as a complete oscillation. Okay, so this is a pendulum, and the movement of pendulum is known as oscillatory motion. The motion of pendulum is known as oscillatory motion, and this process is called oscillation. Initial position, mean position to is just final position, and again returning to initial position. This is known as oscillation, a complete oscillation. Okay, here is other type of motion also: vibratory motion, periodic motion, non-periodic motion, multiple motion, rolling motion, and random motion. I will discuss them in next video.